So one research that we conducted at Exaforce was usage of AWS or different cloud provider features and services as attack tools. One of those services is the AWS CloudControl API. Now, what we will look into this short video will be what the AWS Cloud Control API is, how we can use that as an attack tool, and how we approach detecting it. What AWS Cloud Control API is the AWS version of CRUD-L operations, create, read, update, delete, and list resources. It has 5 API calls and 2 others which are just there to list the requests that are being made towards the endpoint. And it uses the AWS CloudFormation definitions to just have one endpoint manage the whole AWS IP space and all the services and resources inside it. So to make it easier, in a normal resource retrieval, what we will do is we will go for listing the resources and then grabbing all the information that we see important from that resource. How Cloud Control API does it is it will allow you to list all resources using list resources, which will get through the first step, and then you can run get resource for each of the resources retrieved, so that we will be able at the end of get resource to retrieve all of this information for each of the resources. So we can retrieve this information for an IAM user, but each resource will have its own definition in CloudFormation. That way, we skip executing 5, 6, 10 API calls by just changing it to just one, which leads to us as attackers to have it an easy enumeration of resources, because one, we can just list all the resources and then through a loop run get resource for each one of them and then retrieve all the information that we have. And if we don't have access to list the resources first, what we can do is we can have a list of potential names and then run what it's called the resource fuzzing, or resource, as I like to call it, resource brute force, meaning go and run get resource for each one of the resource names and then either get an access denied, resource not found, or retrieve the information. Access denied if we are not allowed to, by which point we can just skip that the call, the whole attack, because it will be very noisy. We can get a resource not found, which means that resource does not exist, so continue to fuzz, or we can just retrieve information, which is what we wanted. The other part of the CRUD-L operations are the create, update, and delete, all of which will have API calls of their own. And for create and update, you will have to input your own CloudFormation definition. The delete just requires the identifier to delete the resource. Now, as I said before, there are 2 other API calls which list and get the requests for create, update, and delete. And in that, we can see the request being made, which can be a success, as in this case, or it can be an error. And if we can see the error, we will see that it says it fails because IAM create user is not allowed to be executed. Now, if you can see it, if you follow up to now, you will see that we never executed IAM create user. We just executed create resource for an IAM role. How AWS Cloud Control works is that it will bulk together all the API calls that are needed for a specific execution, and then execute them in the right order to go and either retrieve, list, or just do any other operation that it needs to do. The problem with this is that if we are not allowed to execute one of the permissions, the whole flow will fail. So right now, what we have is the is an API endpoint which fails at just one event being denied by us. Now, why is that important? Why do we care about this endpoint in the end if we can just use the AWS API and then just granularize all the permissions? Well, one thing that I found out is that, one thing that I found out is that we can abuse the AWS policies and we can abuse the CloudControl API to persist undetectably in AWS. And how it works is we can ask AWS to deny all the permissions except for cloud control related permissions and allow everything else only if it's being proxied through the cloud control service. It will show as CloudFormation because cloud control uses CloudFormation in the backend. Now, after we create and attach that policy, we can see in the policy analyzer that we are only allowed one service, access to only one service, and the policy simulator, on the other hand, does confirm that, as we do not have any access except for Cloud Control API. If security admin will go through the will try to execute any commands that is not cloud control, they will be denied because they will not have access to that. They will be denied of this execution. But if they try to run any execution that they want through cloud control, they will have that access. So right now what we have is a shadow admin or a proxied admin through another service. We do have administrator access, but we only have administrator access because a service is allowing us to have administrator access. And this will bypass a lot of detections on the account. Now, aside from the article, we are also releasing a tool called CloudConqueror, which is a four-parter tool allowing us to list resources, run list resources, and get resource for each one of them. It will allow us to brute force resources through a high number of get resource requests. It will allow us to persist using the technique that we saw with a user or a role, which by default have the name CC user or CC role, but we can also add our own and look through the CloudTrail and try to find misusage of any of the abuses of cloud control. Now, at Exaforce, we do, of course, detect those misusage. As we can see from the identities, we do detect, even though the identity will have the policy that we said will be hiding an admin or will creating that shadow admin, we are able to detect that the roles that we created will be admins. And of course, we will be able to detect misusage of cloud control through for all the operations for listing, brute force, and create, update, or delete. In this case, for example, we are able to detect the create role done through Cloud Control API from the identity Bleon user. In another case, we will be able to find the user, Bleon user, was able to assume admin role and then tried through admin role to execute get resource with too many errors, which led to an unusual behavior of both Bleon user and admin. So yeah, in the end, thank you very much for everything, and hope you liked the article and the tool. And if you have any questions, this will be a post in X and LinkedIn, so you can just ask a question there, and I will try to respond to any questions you might have about this technique.